In this sequence of videos, we're going to discuss solving exponential and logarithmic equations. Let's discuss a little bit about what we're going to do and why it's useful. So let's take a very practical problem. Let's say I invest $10,000 compounded continuously, and let's say we have an interest rate, so with an interest rate of 5%. So we know that the amount of money that we'll have, A of t, depends on the amount of time that we keep our investment, t. This is going to be 10,000 e to the 0.05 t. And currently we can ask questions such as, if I invest for 10 years, how much money will I have? If I invest for 100 years, how much money will I have? But suppose you wanted to ask the question, how long do I have to invest my money how long do I have to invest for to obtain $20,000? So now this problem is a bit different than just asking, okay, I invest for 10 years and I put 10 in for t and I see how much money I get. Instead, we're asking, what is t so that this quantity is 20,000? So let's go ahead and write that. Find t so that 10,000 e to the 0.05 t equals 20,000. This statement here is called an exponential equation. And there are a wealth of different other examples that use exponential functions in their modeling, which also result in exponential equations. You could have the population of some bacteria in an agar. You could be looking at a carbon dating problem where the carbon in a certain fossil is modeled by an exponential function. And all of these could lead to questions that result in exponential equations, just like this investment problem led or could possibly lead to a question which involves an exponential equation. Find t so that 10,000 e to the 0.05 t equals 20,000. Now in this section we won't focus too much on the setup, that is the word problem that comes before the exponential equations. Instead, we'll simply see something along the lines of find t so that 10,000 e to the 0.05 t equals 20,000. Or perhaps it'll say solve this exponential equation for t, or solve for x, etc. And we'll also look at equations which have logarithms in them. But you should know that the reason why we're solving problems such as solving these exponential equations for x or t, or solving these logarithmic equations for x and t, is because they come up in practical situations in the sciences.